Okay, students, today we're going to talk about properties of logs now. So, a multiplication of logs, if I have a multiplication of a times b, that's multiplication, I can separate those out into a plus b. Same base, doesn't change, okay? And I can also go backwards. That means if I start with log of base x of a plus log base x of b, I can move them back into one log, okay, of multiplication. So it goes both directions. All right, so this, when I go from one log to two logs, that would be expansion. I'm expanding, okay, which makes it longer. And then this would be simplifying. Simplifying into one log this side, okay? Same for division. Division of division, I can separate that or expand that out into subtraction of logs. Or if I start with subtraction of logs, again, it's got to be the same base, then I can switch it back into a single log of division. And lastly, when I have an exponent right there on the domain, I can pull that out front, which puts it right there. Or if I have one out front, I can put it back up top there where it came from. Okay, both directions. Okay, so this is what we're doing here, using that information. To use log base 3 of 28 is approximately this, and log base 4, or log base 3 of 4 is approximately this, to approximate the value of each expression. Okay. So what they're saying is, I need to use only 28 or 4s involved. Okay. Now, the one thing they didn't talk about, log base, unless I skipped it on the previous one, log base b of b. So if the base in this domain here, the x value here is the same, that equals 1. Okay, just so you know that. You need to know that. Okay, so notice 36, I can break down to 9 times 4. Well, 9, there's the 4 part right here. Okay, there's my 4 I have. And 9 is 3 squared. Why am I doing 3 squared? Because I know log base 3 of 3 is 1. Remember that 2 then can come out front. And so that's what you see right here. And then so I pull it out front. Okay, and log base 3 of 3 is 1 times this 2 is 2 right there. Plus log base 3 of 4, which we have right here. So 2 plus that is approximately this right here. Now this isn't as much use anymore unless they want to test you on your skills and whatnot, because you can just play this in a graphing calculator and have it kick out the answer for you. But again, when I was in school, we didn't have graphing calculators that could do any of this stuff for us. Even scientific calculators are limited. Okay, so we need to be given these log. In the back of all our books had log approximations we'd have to use. So again, you see, if you knew that 4 to the 4th was 256, because 16 times 16, then I'll pull that 4 out front, and log base 3 of 4 we know is this, so 4 times that is that right there. Okay, log base 3 of 7. You say, whoa, I don't have anything up here. It says 7, but I do have 28 divided by 4. That's what they did right here. 28 divided by 4 is 7. That's the same thing. And I know what log base 3 of 28 is, and log base 4. Remember, division of logs can be separated into subtraction of logs. So now they went ahead and subtracted those two numbers, and there's your answer right there. Okay, so that's what they're wanting to do on this side right here. Not use your calculator, but actually show your steps to get that. All right, next side, properties of logs. Solve each equation. So this is where we're going to put them together. We have multiple logs. Okay. Get down to 1 log on each side. Once I get down to, that'd be simplify. That means combine them down to 1 on each side of equal sign. Okay. Or you might be able to move it all over to one complete side as well sometimes and do that. Okay, all right, so let's do this. So remember, this 2 came from up here. Just so you know that. Subtraction of logs is the same as division of logs. So now I have x squared that was up top divided by 4. Now it's a single log. Equals log base 325. Well, so log base 3 is the same, so that means now this has to equal this. So that's what you see right here. And now we just solve it. Multiply by 4 on both sides, x squared is 100. And then take the square root of both sides. Remember, this squared tells me 2 answers, so it's plus or minus 10. But remember, I have to now plug it back in, because I can, after I plug it back in, I can only have positive answers. So I plug in negative 10 into here, that gives me negative 10. That does not work. So that negative 10 is an extraneous solution, as it points out right there. So the only real answer is positive 10. Okay. B. Again, we have 2 logs, so we want to get down to 1. Again, addition can be changed to multiplication. So move this together as a single log with x times x plus 2. Multiply those together to Schroeder property, and you get this. Now I have a quadratic. Oh no, so they did 2 steps here that I didn't show you. Then they changed it to exponential form. Remember, 2 cubed is 8. So they did that right there. 2 cubed. Change it from logarithmic form right here to exponential. Okay. And now I have a quadratic, so I said equal to 0, solve. And it factors nicely. I get 2 or negative 4. Again, I have to check both the answers. If I plug a negative 4 in there, I get a negative. So it's automatically negative 4 does not work as an extraneous solution. Only 2 works. That will give me a positive answer for both. Okay, so you have to remember to do that. All right, that goes ahead and finish that off, 7.5.